So we're going to pick up now with our next case study, which is something called the BarrierTaskGang case study. And this will show how to customize the TaskGang framework using different Java barrier synchronizers to implement an embarrassingly parallel application that concurrently searches for words in a list of input strings. Now, we've used this particular capability before. We've used the TaskGang framework a couple of times previously. This is going to use it in a different way than we've used it in the past. So we're going to start talking now about the BarrierTaskGang case study. As you can see here, it's got the TaskGang superclass we've used before, which defines a framework for spawning and running a so-called gang of tasks. Remember, we're using the word gang in a loving and caring way in this context. The driver program, which we're going to focus on in this first part of the lesson, is called BarrierTaskGang Test, and it runs various specializations of the TaskGang framework to showcase different Java barrier synchronizer capabilities. And if you take a look at the videos that are coming up in the course, we've been covering barrier synchronization. I will recap some of the key barrier synchronizers here as we get a little further into this case study, but that's what you should be focusing on as part of the companion videos that go along with this lesson. So let's take a look at the BarrierTaskGang test class. This customizes the TaskGang framework to search for words in lists of string objects using various barrier synchronizers. And the emphasis here is on lists, as you'll see here shortly. There are a number of different tests to run. There's one test that's called one-shot countdown latch, and that uses a countdown latch, which we'll talk about. It's a common Java synchronizer for barriers that waits for all thread objects to finish concurrently searching the input for a list of words. So that's the first type of thing. That's going to only be one shot, just going to run one time. And you can see the code that goes along with it here at this link. Then we're also going to use something called the cyclic barrier test. And this is going to run multiple times. It's going to have a cycle, and it's going to keep searching a fixed number of input strings using a fixed number of thread objects until there's just no more input to process, until all the input has been exhausted. And for this, we're going to use a cyclic barrier. And of course, you can find the code for this at the link at the bottom of the slide. And then the third and final test to run is called cyclic phaser, and it's going to use yet another Java synchronization mechanism, a synchronizer for barriers called a phaser. And it's also going to use a cyclic barrier to concurrently search for a variable number of words using a variable number of thread objects until there's no more input. And you can find that code at the link at the bottom of the slide as well. Now, as usual, we're going to define ourselves a factory method that creates the appropriate test that we're going to be running. And so here you pass in the enum, and it does a switch statement, a modern switch statement. And depending on what the enum says, it'll go ahead and make the appropriate subclass of the TaskGang framework and give it the input to do its thing. Then there's a main method that iterates through all the tests and then creates and runs each of the tests. And that's just a simple for each loop that walks through each of the test values, calls make TaskGang, which is the factory method, passing in the word list and the test, and then it runs the object that comes back to do the actual testing. Let's talk briefly about the option singleton. This uses the good old singleton pattern from the Gang of Four book to handle command line option processing. And the main thing I want to draw your attention to are the various input strings we use here. One is called the one-shot input string, and this is an array of strings, and there's just one array element here, which contains the strings we're going to be searching, and we use that for one-shot search with countdown latch. Then there's also a fixed number of input strings where there's multiple cycles, and we use that for the cyclic search with cyclic barrier test. And then finally, there's a variable number of input strings, which is called M, variable number of input strings. And as you can see here, it has different numbers of input strings. The first one is one string. The second one has 5 strings. The third one has 2 strings. The fourth one has 1 string. And then the final one has 3 strings. And this is used for cyclic search with phaser. And you'll see why we have different numbers of these strings as we look through the example. And then we have the array of search words to locate in the input strings. And this is just the names of the musical notes plus OO. And this is used as the input to all the barrier synchronizer subclasses. So with that, let's go ahead and take a look at the code. So here we are in the BarrierTaskGang project. Let's click on BarrierTaskGang test. You can see that this is the test driver that shows off the different Java barrier synchronizers to implement an embarrassingly parallel app that concurrently searches for words in one or more lists of input string objects. And here's our enum that contains the tests we're going to run. Here's the main program that iterates through all the tests. And for each test, it makes the TaskGang with the word list and the test. And you can see down here, we have make TaskGang, which is a good old factory method that will do a newfangled switch construct where we switch on the choice. And if it's a one-shot countdown latch, we make a new one-shot search with countdown latch instance. If it's the cyclic barrier, we make a new cyclic search with cyclic barrier. And if it's a cyclic phaser, we make a new cyclic search with phaser object. And then those are returned. As you'll see when we look at them in more detail, they all implement runnable. So we get back an object and we run it. So that's the main driver program. We will, of course, run this later and examine the output after we've had a chance to take a look at all the different types of tests.